Hello everyone, welcome to ZT online course. I'm the lecturer of this course, Zhang Dong. Today's course is LTE handover and data configuration. Let's go to the content of this course. From this course, we will study four parts. The first part is about overview of LTE handovers, and the second part is LTE handover procedure analysis. The third part is even A3 triggered handover parameter configuration, and the last part is handover data configuration flow. Okay, let's go to the first part, the overview of LTE handover. And we can see in LTE, normally we have two types handover. The first is mobile assisted handover, we named MAHO. The second type is backward handover. So what's the difference between these two handover? We can find the mobile assisted handover, the network and the UE measure up and downlink radio parameters, and UE periodically send measurement to the network. So this can reduce the signaling load and the low handover delay. And the second type is backward handover. The backward handover, we can see the UE network is exchange handover information on old paths. So the UE can recover the connection with source if the handover fails. Okay, we can see the classification of LTE handover. From this slide, we can find the LTE handover has two types. The first type is intra-LTE handover. The second type is inter-RAT handover. Intra-LTE handover, that means the handover just happened in the LTE system. And in intra-LTE handover also has the intra-FDD handover or intra-TDD LTE handover, or between FDD LTE and TDD LTE handover. And inter-RAT handover, that means the handover happen in different systems. For example, if one UE from LTE handover to UMTS, from LTE to GSM, or from LTE to CDM 2000, we are all named inter-RAT handover. And handover classify also can classify by the triggering types. The first type is a network coverage base. I think it is a very normal type. So that means if the UE move to a new coverage, it needs handover. And the second is load triggered. So that means if the if the network find now there has a high load, it also needs handover. The third is based on the service. That means different services we have the triggered handover. Okay. And now we can see the intra-LTE handover. And in intra-LTE handover, we have inter-E-node-B handover and inter-E-node-B handover. Intra-E-node-B handover, that means the handover just happened in the same E-node-B. So that means no need like X2 interface and also no need core network. So we can find the handover just from source cell to target cell. Okay, to the target cell. And the source cell and the target cell, they belong to the same E-node-B. Of course, the first step, the UE, first it will send measurement report to the source cell. And after source cell receive the measurement report from UE, the source cell will do the handover decision. During the handover decision, the source cell will send handover request to the target cell. The target cell received handover request. The target cell will allocate radio resource. Will allocate radio resource for this UE. After that, the target cell will feedback handover request acknowledged to the source cell. If the source cell received handover request acknowledged, that means the handover can execute. So the source cell will send RC connection reconfiguration comment to the UE. This message just include the target cell information. Just inform the UE. Now you can hand over from source cell to the target cell. Okay, if the UE received RC reconfiguration message, the UE will execute handover. After handover, the UE will connect to the target cell, and the UE will send handover confirm to the target cell. And this message is RC reconfiguration complete message to the target cell. Okay, after that, the target cell and the source cell, the resource will be released. So the intra-inode handover will be finished. Okay, the next type is inter-inode handover. That means that this handover, it will happen between different inode. For example, in this slide, the handover happened in inode 1 and inode 2. And the inter-inode handover also has two types. The first type is X2 based inter-inode handover. So that means if the inode 1 and inode 2 has X2 interface, okay, it will trigger X2 based inter-inode handover. If the inode 1 and inode doesn't have X2 interface, we will trigger S1 based inter-inode handover. So if we use S1 based inter-inode handover, it needs core network. Okay, now we can see the X2 based inter-inode handover. The same, the UE, first the UE will send measurement report to the inode 1 because now the inode 1 just like the source inode. And the UE will measuring the serving cell information and target cell information to inode 1. And the inode 1, after inode 1 received the measurement report, he need to do the judgment. Okay, after judgment, the inode 1 will send handover request to the inode 2 through the X2 interface. If the inode 2 received handover request, that means, okay, now there has one user want to hand over to my cell. So the inode 2 will perform admission control and allocate dedicated resource. So after the resource allocated, the inode 2 will send handover request acknowledged to inode 1. If the inode 1 received the handover request acknowledged, that means now handover can be executed. So the inode 1 will send RC connection reconfiguration message to the UE. This message just like handover confirm. Okay, if the UE received RC connection reconfiguration message, the UE will start to hand over to the inode 2. This procedure we can think just like a random access. So you can see that's why number 6 and the number 7 step just like random access procedure. Okay, and in number 5 step we can see between inode 1 and inode 2 they also need SN status transfer. Here SN status, that means sequence number status transfer. That means the inode 1 should send the PTCP sequence number to the inode 2. So that means the inode 1 will send all the information of this UE to the inode 2 because now this UE has ready to hand over to the inode 2, right? Okay, so after 6 and 7 steps, that means the UE has already hand over to the inode 2. So the UE will send RC connection reconfiguration complete message to the inode 2. Just inform inode 2 now I'm already arrived your cell. Okay, if the inode 2 receive this message, the inode 2 can confirm this user has already hand over to my cell. So what's the next? The inode 2 should send a message to the core network. Why? Because now the inode change. So that means if later the core network sends some information to the UE, he need to send to the new inode. So the new InnoB should inform the core network, just like number 9 message, the path switch request. The path switch request just like tell the MME, please update a new path to the UE. Okay, actually the MME received the path switch request. The MME also will send the path switch request to other entities in core network. For example, like SGW, PGW. Okay, after that, the MME will feedback the path switch request acknowledge. That means the core network also update the new information. Okay, after that, the eNodeB2 will send a UE context release to eNodeB1. That means now all the procedures of this handover are finished. So if the eNodeB1 receives the context release, the eNodeB1 will delete the UE instance. So the handover is finished. So we can see for the X2 based handover, no need core network, right? So the eNodeB1 and the eNodeB2, they can communicate directly. Okay, we can see the next type is S1 based inter-eNodeB handover. S1 based inter-eNodeB handover actually means maybe between eNodeB1 and eNodeB2 there are no X2 interface, or the X2 interface now is invalid, cannot be used. So how to do it? The same. The first step, the UE will send management report to the source eNodeB. And also this management report will include my serving cell information and the target cell information. But now the eNodeB1 cannot find the eNodeB2 directly because now there's no X2 interface. So the eNodeB1 will send handover request to the core network, to the MME. Just let the MME help to find the target eNodeB. Okay, if the MME receives the handover request, the MME can through the target cell information, he can find target eNodeB. Okay, so number 3 step, the MME will send handover request to the eNodeB2. The same, if the eNodeB2 receives the handover request, the eNodeB2 will allocate the dedicated resource to this UE. Okay, to the UE. After the resource allocated, the eNodeB2 will feedback the handover request acknowledgement to the MME. Okay, if the MME receives the acknowledgement, he will feedback handover comment to the source eNodeB1. So after number 5 message, the eNodeB1 will clear now the handover can be do it. So the eNodeB1 will send RC connection reconfiguration message to UE. Also, this message will include handover confirm. After UE received RC connection reconfiguration, the same, the UE will do the random access, try to access to the new eNodeB. And the same, the eNodeB1 will send some SN status to the eNodeB2. The same problem. The eNodeB1 cannot send information to eNodeB directly, so it need to send to MME, and through the MME send status to the eNodeB2. Okay, so number 9 and number 10, that means the UE will try to access to the eNodeB2. After access, the UE will send a RC connection reconfiguration complete to the eNodeB2. Just inform the new eNodeB. Now I'm success to handover. After that, the same, the eNodeB2 will send handover notify to the core network. Just inform the core network. Okay, now this UE has already handover to my eNodeB. Okay, and after that, the core network will send the UE context release comment to the eNodeB1. If the eNodeB1 receive this message, okay, he will release all the context of this UE. After that, the UE will feedback complete. So this handover will be finished. So we can see X2 based inter-InnoB handover and S1 based inter-InnoB handover. Of course, for time delay, the X2 based is lower than S1 based. So in real network, if we have X2 interface, we prefer to trigger the X2 based handover. Okay, so this is the first part, just give you the overview of LTE handovers. We can see in LTE system, we have intra-LTE handover and the inter-RAT handover. And for intra-LTE handover, we also have intra-eNodeB handover and inter-eNodeB handover. And inter-eNodeB handover, we have X2 based inter-eNodeB handover and S1 based inter-eNodeB handover. Okay, let's go to the second part, LTE handover procedure and analysis. And this is the complete LTE handover procedure based on the X2 interface. I think this procedure we have already explained in the previous part. So we can see in here, number one, also UE will send the management control number one step is the source InnoB. First, we'll send management control to the UE. Just inform UE which information you can measure and after measure how to report to me. Okay? After UE received this management control message, the UE will start to measurement. Once the UE finds some target cell satisfy this condition, the UE will report the measurement, just like the second step, measurement report. So after that, number 3, number 4, number 5, number 6, and number 7 is the same like previously. We have already explained before, right? So after number 7, okay, this is number 7, just like the source InnoB will send RC connection reconfiguration message to the UE. Okay, after UE received the number 7 message, the UE will start to access to the target InnoB. And also during this procedure, there is a SN status transfer, and we know SN means is a PTCP sequence number status transfer. Okay, so 9, 10, 11, just like access. Okay, access. So after access, that means the UE has already success handover to the target InnoB. Okay, and the target InnoB will send some information to core network. Just like he will send the path switch request. Just inform the core network. Now the path need to update. So the MME after receive this message, he need to inform all the entities in the core network. Okay, after that, he will feedback the path switch request acknowledge, and then the target InnoB will send a message to the source InnoB to release UE context. So totally we can see in LTE handover there are 3 steps. The first step is handover preparation. The second step is handover execution. The third step is handover completion. Okay. So this is the signaling flow of the handover procedure. I think it is the same, right? First is from eNodeB, send management control to UE. Just tell UE which parameters, which information you need to measuring, and after measuring, how to report. Okay, and the second is management report by the UE. Okay, and the third is handover decision. This is decided by source InnoB. And the fourth, handover preparation, just like the source InnoB and the target InnoB, they need to negotiate the handover. After that is handover execution, just like the source InnoB will send a comment to the UE, please to do it. Okay, the last step is handover completion. That means all the handover procedure finish, the UE will feedback the handover complete message to the target InnoB, and the target InnoB will inform to the source InnoB, and all the link will be released. Okay, and we can see each steps in details. First is measurement control. We just mentioned before. In the measurement control, just like the E not B will send this message to UE, just tell UE which information, which message you need to measure, and after measuring, how to report. So which parameters in this IE we in this procedure we can see the first is a measurement object. So measurement object just tell you okay which target cell, which frequency you can measure, and this is a report config. Report config is like maybe you need to uh, report by event or report by time, and also just report one time, or you can report 2 times, 3 times, 4 times, just like that. Okay, and when you report, please report the measurement ID. So which ID you want to measurement, and quantity config. Quantity just like you can report RSRP or RSRQ, right? Or you can report RSRP and RSRQ. And the third is S measure. This is the measure threshold of the serving cell. And this parameters, the range is from 0 to 97. From 0 to 97. The related RSRP value is from minus 140 to minus 44. So the index of these parameters is from 0 to 97, and the corresponding RSRP value is from minus 140 to minus 44. For example, if the 00, that means minus 140. If the 97, that means the maximum one is represent minus 44. Okay. Next is a measurement report. So the UE will report measurement result to the InnoB, right? So which information? First, we can see the measurement ID, because this ID has already sent by the measurement control message. For example, here the UE report measurement ID is 3, okay? And the UE will report the measurement result of serving cell and the measurement result of neighboring cells. So we can see in here, the serving cell he report RSRP result 35, RSRQ result 32, and also for the neighbor cell, we can see here for the neighbor cell he also report RSRP and RSRQ, and also include the neighbor cell PCI. And here please pay attention. This here RSRP 35 not means 35 dBm. In here 35 should minus 140. Okay, should minus 140. So actually the RSRP 35, that means minus 105 dBm. Okay, and RSRQ is 32, also cannot not mean 32 dB. 32 means this value should minus 40. Minus 40 is minus 8, right? And minus 8 and divide by 2. So that means this value is minus 4. Okay, it's minus 4 dB. So you just remember RSRP value in here, they all need to minus 140. And RSRQ value should minus 40 and divided by 2. So for the neighbor cells, RSRP and RSRQ is the same. Okay, after that is a handover decision. And we know the handover decision is between source in node B and the target in node B. And in handover decision, you can see there has so many messages in this procedure. For example, the course. That means, of course, here the course means handover. It's based on the coverage handover, based on the load handover, based on the service handover, right? And here is the target ID. Okay, and UE context information. And this is a SAE build ID. SAE means system architecture. This means core network build ID. And the core network build QoS parameters and RC context. Because this message, the old inner B should negotiate with the new inner B. So it needs so many informations. Okay. Okay, the next is a handover preparation. Handover preparation you can find now the old inner B and the new inner B, they are prepared to hand over. First, then they should allocate an ID to the so we can find there are two different ID. The first ID is allocated by the old inner B to the UE. The second ID is allocated by new inner B to the UE. And this ID, please pay attention, they are temporary ID, just to let the inner B to remember, okay, who is this UE? And also just let the new inner B to remember who is this UE and to do the handover. And the next is a handover execution steps, right? Execution steps, you can see there is a two part. First is handover execution in source inner B. Second is handover execution in the target inner B. In the source inner B, of course, the source inner B will send RC connection reconfiguration message. And this message will include all the target sales information. Okay, all target sales information. And after UE received this message, the UE will start to hand over. This procedure just like a random access. Okay, after access to the target sale, the UE will send the second message. This message is RC connection reconfiguration complete to the target inner B. Just inform the target inner B now I'm finished. Okay, so during the handover execution steps also include other procedures. For example, the SN status transfer. I think we have already mentioned in the previously, and path switch request, right? The target inner B will send the path switch request to the inner B, and if there has a S1 based inner B handover, they also need to modify the BEARS request message. Okay, so that means the old core network also need to update the information. Okay, so this is the handover execution steps. Last is a handover completion. Completion also there has a X2 based handover completion and S1 based on the handover completion. X2 based is easy, just like the new inner B will send the message to the old inner B. This message is a context released message. But for the S1 based handover completion, then they need two steps because they need to send core network, and through the core network send to the old inner B. So the first page, this page is new inner B send context release comment to the MME, and the second is MME send this message to the old inner B. Okay, so this is the second step, is a LTE handover procedure analysis. Let's go to the third part, even A3 trigger handover parameter configuration. Okay, this is the management event for LTE handover. As we know, LTE we are divided into intra-LTE handover and inter-RAD handover. For intra-LTE handover, we can also say intra-U handover. There has a one step is a handover decision, right? So that means the inner B should judgment whether you need to hand over or not. But how to decision actually is based on the event. So now we will study the event in LT. And we can see in intra-EU trend handover there are 5 events. Okay, in event A1 and event A2, they cannot judgment handover, but they can decide what? they can decide when you start measurement and when you stop measurement. That means in LTE system, the UE not always measure. Okay, so if the even A1 report, that means you will stop measurement. That means no need. That means no need measurement. Why no need measurement? Because if the even A1 report, that means the serving cell now is become better than a threshold, and then this threshold is decided by us. And A2, that means you need to start to measurement. That means now the UE find the serving cell worse than the threshold. Okay, so you just remember A1 just tell you when you stop measurement, and A2 just inform you when you start to measurement. Okay, after measurement, how to judgment? In LTE system, judgment is based on the A3, A4, or A5. Please pay attention. It's all, not and. So that means during the handover judgment, we can select one of them. And normally, we select A3 because even A3 is easy to judgment. Why? Because even A3 we can find if the neighbor cell quality become better than the serving cell, maybe P cell or PS cell. Because here means if we are using the carrier aggregation, maybe there's primary cell or primary secondary cell. So that means if the neighbor cell become better than serving cell, okay, you can hand over. So even A3 is normally used for the coverage based. What about A4? A4 is normally used for the based on the load handover. For example, if we find we need to load the balance, okay, we can use even A4. So we can see even A4, that means if the neighbor cell's quality become better than the threshold, the UE can be handed over. We can find in here there's no any information about serving cell. So that means just the neighbor cell's quality become better, you can hand over. Okay, and even A5. This means first, my serving cell quality should be lower than threshold, and the neighboring cell quality should be higher than threshold. These two conditions, they are all satisfied. The UE will be handed over. So we can find for the A5, if we use this event, triggered handover is not easy, right? So normally we are using the A3 because A3 it can be fast to trigger handover. Okay, so this is intra-EU handover event. And the second is inter-RAT. Inter-RAT also has two events, B1 and B2. B1 is similar like A4. B1 is for the load based on the load handover in different systems. For example, if the UE want to from LTE handover to the UMTS system based on the load, okay, we can use B1. And B2 is similar like A5. That means should be LT serving cell less than threshold and the UMTS neighbor cells quality higher than threshold. They are all satisfied, we can hand over. So this is the odd event in LT handover. And I also mentioned normally we are using A3, right? So now we can see the even A3 in more details. In even A3 we say just if the neighbor cells quality better than serving cell quality, the UE will be handed over. So in here we can find MN, that means the neighbor cells quality. MS is the serving cell quality. So, but we can see besides MN and MS, we also have some other parameters, right? The other parameters is useful can control the handover is early or late happen or easy or hard happen. So we can see for the neighbor cells, we will minus a parameter is this parameter named hysteresis. For the serving cells, we plus a parameters is offset. So that means only the neighbor cells quality is much better than serving cells quality. It will be handed over, right? It will be handed over. Okay, so here they has a A3 offset. This A3 offset just used for control. The neighbor cell's quality should be much better than the serving cell's quality, and then the handover it will be triggered. And normally this value, in practical, we suggest to set 3 or 4 dB. These parameters cannot set too big or too small. For example, if you set too bigger, that means handover is very, very hard to trigger. But if you set this parameter is too small, handover is easily to trigger, but the quality cannot guarantee. Maybe after handover, it's still a call job. So in real network, we recommend to set 3 or 4 dB. Okay, the next is the TTT, time to trigger. These parameters is also very important. These parameters to avoid ping-pong handovers. So that means even we find the neighbor cell's quality now is better than serving cell quality, but still need to wait a time. After this time out, if the neighbor cell quality is still better than the serving cell quality, you can hand over. So this timer is TTT. And this timer has different options. And the default value is 320 milliseconds. And this timer we should base on different scenarios to set. For example, if our cell is a low speed cell, this parameter should be set a little bigger, right? If our cell is a high speed cells, this value which we suggest to set a smaller. Okay, this is the hysteresis. This hysteresis, this is the same. This hysteresis is used for control the neighbor cells. So if this value is if this value is set too bigger, okay, if this value, for example, the greater the hysteresis, the stronger the signaling of the neighboring cell should be meet the entry condition. So that means if this parameter set too bigger, the neighbor cells very hard to greater than the threshold. So the handover is very hard to trigger. But if this parameter set too small, the neighbor cells is easily to it's very easily greater than the sums, but the quality cannot guarantee. So in real network, the default value is 1.5 dB. Okay, CIO. These parameters in real network we suggest to set to 0 because now we have already used the A3 offset to control the neighboring cells. So these parameters normally no need to modify just by default. Okay, and this is a report on leaf. Report on leaf. This is the same like previously report on enter, right? So if that means if the serving cell quality greater than neighboring cell, that means now no need to handle. So you will be report on leaf. Okay, and normally this value is default is false. We are not used. Okay. And the next is a report interval and the report amount. So that means if the UE find there's one neighbor cells satisfy all the condition, the UE need to report. How to report is based on these two parameters. The first is a report interval. Report interval, for example, we recommend the report interval is 480 milliseconds. So that means the UE will report the result by each 480 milliseconds. Okay, and the report amount we also suggest to set infinity. Infinity just means always report until the ANOV received the report result. Okay, report result. Okay, the next is parameters for even A3 about layer 3 filtering. This is filter coefficient because we know the UE measuring the target cell result is not always the same, right? For example, I report 3 times or 4 times. Maybe these 3 times or 4 times result, they're all different. Maybe the first time is minus 105 dBm, second time is minus 106 dBm, the third time is minus 104 dBm, right? This is very common. So what is the filter coefficient? If the filter coefficient we set 1, choose one report for the final judgment result. If you select, for example, if you configure these parameters to 3 or 4, for example, the default value is 4. The value is 4, that means, okay, I will collect 4 report result and divide by 4. We will get an average value, the average value. So that means if these parameters, if this value increase, that means the result is more close to the real value, but it will cause long-term delay. If this value is too small, the short-term delay, but this result cannot, maybe it's not, maybe it's not very close to the real value. Maybe it will cause handover fail. Okay, so the default value is 4. Okay, and this is S measure. S measure we have already mentioned before, right? The report value is from 0 to 97, and the different value is represent different real RSRP value. For example, if the 00 that represent minus 140, and the 97 is represent minus 44. Okay, so this is the third part. This is about A3 trigger parameter configuration. The last part, just like handover data configuration flow, we can see when you log in the our net Newman, and from N Newman, first going to the radio parameters, LTE, FDD, and there has the UE EU train management, right? And in UE EU train management, in here we can set all the parameters. For example, we can set management ID and management type and management quantity and like down some event, some threshold. They all can set in here. And next is about also is about the management parameters. This is more details to config. Okay, and the next is about the neighboring cells. For the neighboring cells, we can see they has a FDD neighbor cell configuration and neighbor relation configuration. In the neighbor cell configuration, just like we need to configure the neighbor cell information, like a neighbor cell ID, InnoB ID, like a neighbor cell frequency. Okay, we can configure it here. And the next is about the neighbor relation, like what's the neighbor relation between this cell to my serving cell. Okay, we also can configure it in here. Okay, configure in here. So this is the configuring configuring handover related parameters in our NetHuman. I think this is not uh, complicated to find the position, but how to set parameters should be based on real experience. Okay, okay, so that's all for the other part of this topic. Thanks for your learning.